important to make clear before Sam starts that we're right in the middle of this thing, which is to say they've taken samples, they've gotten results, that's what we're going to talk about today. Field questions from you all, but we still have about 6 months worth of testing yet to come. And so the study is not completed, and our hope, not just from the Soil and Water District or from Sam's team, but the group of folks who've been meeting on the Hondo, is that we can keep testing the water in this river and use the results that we have now as a baseline to understand what's the river like now, and if we see changes, to try and figure out is the water getting better and why, and is it getting worse and why going forward. Without further ado, Sam, why don't you take it away? You can introduce yourself and dive in.
Perfect. Okay, I will try to use my extension voice. I actually started as an extension specialist in Alcalde, New Mexico, working for New Mexico State University in 2001. Can you guys hear me back there okay? All right. So I now work at New Mexico State University, and I'm a professor of watershed management, also director of the New Mexico Water Resources Research Institute. And I really appreciate Peter and Tanya and the Taos Soil and Water Conservation District for bringing us onto this project, because my main goal for our Water Institute is to do work that will help communities better manage their water resources. And I think we try to bring impeccable data and science level research to these issues. That's something that we add. And I really appreciate JR's sort of organizing effort, and of course, I won't go through the whole list of community members that we're working with on other projects, but thanks to all of you for bringing me onto this. What you have for this handout is a draft. It says draft in watermark because it's just the first sort of effort to communicate our water quality study results. And what I'm going to do is I'll just kind of go through the first page. We can take any questions, and then I think based on we had a group meeting yesterday, I'll probably try and get through pages 1 and 2 and then do some questions and then talk about the flow. But basically we have the punchline I'll tell you right now is the Rio Hondo has very good water quality. It does have bacteria, which is expected when you have animals and people in a watershed. And I think the challenge is really maintaining this great quality resource and the amount of water that goes along with it into the future. So that's kind of the punchline. I stole my own thunder there before I even got to it. But if you look at this handout, there's a little bit of an introduction about the Rio Hondo. There's a table which shows some water quality results, and I'm just going to talk about the conclusions first and then go through the results. Basically, we tested metals, including arsenic. They were all below drinking water standards, so it's high quality. All the water quality parameters we tested were in the range of drinking or irrigation water standards, except for one site at one time for alkalinity and chloride, which is not really a water health issue unless you're drinking the water directly, and it was just one location in time. So essentially we tested over 60 parameters, and they're all very good. But let's just go through this table for an example. The maximum contaminant level is the EPA standard for drinking water. And also included here are some of the irrigation water standards, which thanks again to that group for coming yesterday to help me practice, because it made it really clear that the numbers in green, like 180 is an irrigation standard. There is not an actual drinking water standard for bicarbonate, but there's this 180 irrigation standard, which was exceeded at one event for irrigation water. The average for bicarb is 96, and these are all in parts per million. the range of our sampled results. So we took samples and they ranged from 54 to 241 parts per million. And if you go down the table alkalinity, the maximum contaminant level is 30 to 100. The range of our sample was 45 to 197, and the average is 79. So this is one of those parameters that actually exceeded the maximum contaminant level at one time at one location. Sodium absorption ratio is well below the standard. Chloride, this was one event at one time we got a value of 30.4 that exceeded the low end of the standard, but our average was 3. Nitrate, I mean, this is something that has a lot of contamination from waste, animal or human waste. You would expect high nitrate. Also, you see it with fertilizer, but nitrates are very low, 0.26 on average, all below the contaminant standard. Sulfate's very low, fluoride's low. So basically, all of these show very high quality water. And I should mention, these were put together by April Ulrich. She's a PhD scientist who runs a certified water quality laboratory. And she also did the analysis for metals. So if you look at this other table, arsenic, no detect. I mean, there's nothing there, no cadmium. Iron, a naturally occurring substance, was not any drinking water problem, but it did in one case exceed the standard for irrigation water. Those are again those values in green. But we don't have any metals that are above the maximum contaminant level for drinking water. They're all below the standard. So that's great. This next page shows the map. And by the way, JR put together, where's your map?
Back there on the bar. Greg's got it.
So maybe we could hand that around. That shows our sample sites. But these, we sampled a lot of organics, pharmaceuticals, oils. We didn't find any contamination. And this map shows the sample sites that, Carlos Miera or another community member could talk about the way, or Sylvia could talk about the way we came up with those sample sites. Or Peter, of course, who contracted with us to do the work. But basically, all those organics, all those pharmaceuticals, all the oils, greases, all those sorts of things, we did not find any. So, very high quality water, but we did find coliform. So this table that shows total coliform and E. coli indicates that on some sample dates, we've done 9 so far, there are bacteria in the water, and we find that just a quick glance shows there's more in August when there's lower flow, and there's more downstream as you get toward the lower end of the Rio Hondo before it empties into the Rio Grande. So this is something that I think is indicative of having animals and people in the watershed. If you go anywhere, for example, downstream of Albuquerque, there's a lot of bacteria from pets. If you go up to the San Juan River, there's a lot of bacteria from wild birds. About any watershed, if you go and study the occurrence of bacteria, you're going to have bacteria in the water. So this is something that we talked to the local group last night, and it's at this time, this might be an area of future study, but it doesn't necessarily indicate any major sources of bacterial input that are cause for concern. It does say, don't go out and just put your dipper in the water and drink the water directly. And not only bacteria, but there's also going to be pathogens out there like, Giardia, other pathogens basically naturally occurring pathogens that might have an impact on your health. But what we found is that other than these bacteria, all the parameters show very high quality water. And I might as well just blast along and finish up with my presentation.
Let's do it.
Okay. So the last page shows that we also took a lot of data that aren't shown here, and in our future reports we're going to have an update of this report in the spring that includes more of these data. But we also took flow at all of these sites. You can see this map has a revised site with flow data. Because of either the channel structure or access, we weren't able to measure flow at all of the sites where we took water quality samples. But actually we have a team out there right now measuring flow and water quality and taking samples, some for delivery to Hall Environmental. They did the bacteria and organics, and some for delivery to April Oler's lab at NMSU, who did all the nutrients and metals. And they also measure flow. So that's done with a weighting rod where you walk across the stream and measure flow. The way it's done is you measure velocity of the water and you multiply it time. That's going to be in feet per second. You measure the width of your interval and the depth, and that's in square feet, and you multiply them together and you get cubic feet per second. It's the greatest thing. And this graph shows the flow for the different sample periods. There's 9 of them here, I believe. So you can see that there's more flow in the spring, it goes down in the summer, and it goes up again in the spring. And this also shows the USGS site is in orange, so that's higher than the values that are downstream at Shirley Mills and before it goes into the Rio Grande. So this is indicating that there's a relationship some relationships between flow and water quality potentially that we want to try and tease out. But the other good thing is that we see, as you would expect, there's more flow right before the water gets distributed into the acequia irrigation system. But because of returns, there's not a lot of consumptive use overall before it goes into the Rio Grande. So I think an important part about this flow is that even in times of low flow, there's still some flow in the river even in the dry part of the year. And I think as we talk about maintaining, ideas for maintaining quality into the future, we also want to maintain that flow in the river and connectivity with the groundwater, because a really important way to keep flow in the river is that groundwater that's sort of slowly seeping back into the river and maintaining perennial flow. So overall, we have a very high quality source, and some need to understand that you don't want to just drink it straight because of bacteria, but also, like Peter was talking about, you can install, if for any reason you need to drink this water, you can filter it, but it's probably better not to treat it as a high quality recreation, fishery, irrigation resource. And we're going to continue through June of next year. So we're probably going to have another community outreach event in the spring. Is that what I'm hearing?
Or more.
Or more. And this is a living document at draft. It'll turn into a final document, I think, in June when this part of the project's over. But now we'd open the floor. Oh, please, Tanya.
Can you touch on the pharmaceuticals and what the discussions have been around that? People have questions.
Yeah, so there was concern that some of those pharmaceuticals aren't captured by wastewater treatment facilities. So this, my understanding is the reason we were doing that is because there was concern about those getting back into the water from either the upstream Taos ski village or even people's individual water and wastewater returns back to the river farther down, and we didn't find them, but there is a just nationwide, that's an emerging contaminant along with PFAS, which are ubiquitous, we're finding. So we didn't sample for those.
So just, technology's changing every day, and right now we don't know of any way to take the pharmaceuticals out of the water. It's always something that we've been worried about. Hopefully one day the technology will be there to do it. Now the forever chemicals, some of the latest scientific journals are using bacteria to eat forever chemicals. So that's like the latest type of technology for that. So hopefully, you know, you'll have a solution to that. But right now, it is what it is.
I have a question. Was there any testing when the Ski Valley pipes broke down in January or in April?
Could you elaborate on your question?
Well,
And actually, can you say loudly so everybody can
the
hear?
Ski Valley, as we know, had some major breakdowns with their plumbing in January and again in April during the height of the ski season. And a lot of those contaminants may have gone across the road and into the river, and they were worried about that too. And I'm just wondering if there was any testing going on during those breakdowns, or should there have been?
So there's a few, is there anybody from the Ski Valley who can elaborate on what that, I'm not sure what that,
It shows that there were testing dates in the end of January.
Okay.
so
And
we need like exact dates, because what I heard about was broken.
January, it doesn't, yeah, I don't
I heard
know.
about broken supply pipes, but I haven't
That's-
heard about any broken
Pipes, the pipes.
wastewater.
No, it wasn't the wastewater pipes, it was the pipes in the,
Yeah, the supply
in the
pipes, so
road.
yeah, that's not gonna affect.
Right.
The, so everybody, so I don't know if you heard, but Phaedra was asking about when pipes broke in January and April and if we were testing them. So short answer is we did a sample in January that might have been right after that, but the bigger answer I think is that my understanding was that those were, that we just did a tour of the Ski Valley in September, and they told us that the supply system pipes broke, which would have been that fresh water going into the drinking water supply, which would not have directly been like an effect on, it basically would mean that some of their fresh water that would have supplied the consumers wasn't available, but it wouldn't have been a direct impact on the water quality, it would have been an impact on the supply. So that's my understanding of the situation.
Okay, and one more thing. A neighbor of mine who is right on the Acequia Madre, which comes directly off the Rio Hondo, has been complaining for 2 or 3, I guess 2 years now, that there's a very thick filamentous algae in the ditch behind her house. And I'm wondering if there's any thoughts about testing that or trying to find out where that's coming from?
Okay, so the question is about filamentous algae and an acequia. So we actually, that's a great question. Then usually that's happening from nitrogen or phosphorus, because those are like fertilizers in aquatic ecosystems. And I have some experience with this because I worked at the EPA under one of the nation's top aquatic ecologists who studied with like the father of all that, Gene Likens. And that is almost always associated with nitrogen or phosphorus fertilization. And we didn't see any of that in the river itself.
No.
No indication.
That's the problem.
That there's
And
any-
yet there's a mat of filamentous algae
what
in
that
the
leads me to
acequia.
believe is it's some kind of local source that's
Yeah.
in the upstream of that location in the ditch itself.
Right.
So that's a great question because that kind of brings up a whole, I really appreciate, Peter's designing this study. Let's look at the river first. Let's get a baseline. But I'm quite confident that the water diverted off the river into the ditch is not causing the fertilizing effect of high nutrients that would lead to that filamentous algae. So that means it's a localized source.
It is.
Probably in the ditch itself, or it could even be something like in a storage, a pond or something, or there's different ways that could happen.
Okay.
But I'm pretty sure it's not coming off the Rio Hondo.
Okay, thank you.
Good question. Yes, Nick?
Yeah, question just, alkalinity, you had a real high measurement,
Yeah.
you were saying. So we were talking earlier about, I'm a fly fishing guide, and so I've been fishing the Hondo for a long time. And unless I'm just getting worse at fishing, which is possible, noticing catching a lot fewer fish in the upper Hondo. And so, I know alkalinity and pH in particular is something that macroinvertebrates and the bugs that trout eat are, very important. So I'm wondering on that high reading if there's like any other thoughts on that, and then kind of follow-up questions in terms of trout in particular. Are we looking at temperature, turbidity, and other things that would affect the fish in the river in this study, or is it just more the water quality stuff?
Okay, did everybody hear that question? So there's a lot packed into your question, but I want to write it down because so.
How do I catch more fish?
Yeah. So I think something that our sampling strategy was to look at these periodic sampling, like a comprehensive, high-quality analysis of a suite of parameters at selected dates that the community informed us about based on their understanding of some of the issues out there. But we're not capturing what you're talking about. So we did also measure temperature and pH and dissolved oxygen while we were out there taking samples. So I realized that that's something else we need, along with along with adding the flow from up to down in our report. We need to add those other ambient the water quality things that we measured on site. So thank you for that comment. So we do have those data, which may be important for just like the baseline, but we're not going to catch. So we've proposed, I think what we probably need to do is think about some short answer is we have some of those on-site water quality parameters that we can add to this for our next report, but we're probably not going to catch the events without some other sampling strategies.
And that one measurement on the high alkalinity, like, is that, I don't know.
So that was actually all the way down. That was all the way downstream at the site before it goes into the river. So that's not going to explain your fewer fish in the upper reaches.
If you just see that on above.
Right.
Yeah, and that's one of the things we discussed yesterday in a smaller group, and that should be made clear to this group, is that's where Sam and his team have a ton of data.
Yeah.
And to be able to present it in a way that doesn't overwhelm everybody, we're still tinkering with that. One of the things that became clear in this conversation last night, though, and I think is becoming clear today, is you want to know if you see on that range there was a spike at some point somewhere on the river, when, where, and maybe even why. And the why is always hard to pin down, but in that instance, right, that 197.8, that sample was taken at the bridge that you cross as you're headed down to the John Bridge from here before the road turns to dirt. And it was taken in, I think, July of 23. So it doesn't explain why you and I are catching less fish. I think you're probably getting worse at fishing, is at least part of it. I'm getting a lot worse if that's the case, because I'm not catching anything up there anymore. But it is, to Sam's point, if we've got all this data, even if it's not printed out on a sheet that you can take home and make heads and tails of, between now and June of 25, I'm trying to figure out how can we make all of that data available. So if you're curious about pH or temperature or any of this other stuff, add a site on a date? How can we make that easy to access? And then more importantly, going forward, the group that's come together around this, we don't want this to stop in June. The money that we have now stops in June, but we want to know, especially if we can do it in a way where it's capturing constant data, at least in some locations. We've got good baseline data. How do we make sure we're catching data going forward as a monitoring effort? And then to make sure that we're catching those right mechanisms. So all of that stuff.
Yeah, my input would be if there's a way down the road to look at, the game and fish unfortunately just doesn't have a lot of capacity to pay attention. So we were talking about the last fish survey they did there could have been 10 years ago or more, or who knows. So any efforts to do like macroinvertebrate surveys, fish surveys, and so we can, because they're indicator, species, and that will tell us a broader picture. The other one that I've noticed in my lifetime, somewhat anecdotally, but I think more so than that, as we've had more development, especially the upper headwaters, turbidity is an issue in the river where, it used to rain a bunch, the river would continue to run clear. Now we have more dirt roads, just more exposed earth, it rains, and just more development. So I'm seeing more times when the river is just running muddy in that upper stretch, and that can have an impact on macroinvertebrates and therefore trout too.
For sure, I would say, especially based on photos that Phaedra's been bringing to meetings and others have seen in the river, it's not just the headwaters. Like all of that development up above Valdez, on the north side, there's tons of erosion and silt coming into that river with rain events. And as the rain events become more intense, we're going to see more of that. So turbidity is no doubt something we should be on the lookout for. And then if there's ways to mitigate that, through best practices and trying to control and stabilize those slopes where the new roads are, that's like long term, that's the goal of this effort. It's just not to know what's the problem, but figure out what's the solution.
So it's illustrative that the study did exactly what it was intended to do. Because when we first started this project, one, we had never done this had never been done before. Two, we had to figure out how to use what was given to us, the funding, in the best way possible. So the initial strategy was to test for everything and see what came back. Was there a blip? Was there an anomaly? And that's what you had caught right there, is there's an anomaly in alkalinity, right? So that allows us to be able to maneuver and focus on the anomalies. Now, long term, I'm just going to tell you right now that the community along the Rio Hondo has been given a gift, and that gift is that your water's pretty darn good. It's going to be up to the community to maintain that, and you're going to have to do it by working together.
If I may, most of the question was answered, but the native fish, the cutthroat, the native fish specifically, is that the focus, or is it, because I know that river got stocked as well, so rainbows and lots of other stuff, but the native fish, the cutthroat, is not endangered maybe per se by this study, but it's close. There's some discussion of that, and I was just curious if there's any focus on that.
Yeah, not as part of this study. I will say the group had a conversation months ago about wildlife habitat really focused on the cutthroat. The cutthroat trout, the native Rio Grande cutthroat, exists in a handful of tribs. Do you know off the top of your head which ones they are, Nick?
Yeah, so there's, all of them actually.
There's cutties in all the tributaries?
Yeah, and there are some cutthroats still in the main stem Hondo. The biggest threat to the cutthroats is not really water quality in the Hondo, as far as I know, but it's more introduced non-native species, brown trout mainly. The rainbow trout that the state stocks in the Hondo, and I don't think they're really stocking them anymore, but they're all triploid rainbow trout, so they actually they may compete for habitat, but they don't breed with the cutthroats, which is usually the problem. Trout Unlimited and a few other organizations have been working on it's taken a long time. I think we're getting close to getting it done, but to protect the cutthroats in the tributaries like Yerba, Talianos, and Manzanita,
I think so.
to put a slip liner in the culvert where the creeks run underneath the highway. There's a special kind of slip insert that you can put in those culverts to make those culverts an effective fish barrier so that non-native fish can't move upstream. Those cutthroats in those creeks are what they call relic cutthroats, so those are the fish that have been there for millennia. And so yeah, the Upper Hondo is an important place for Rio Grande cutthroats, and it's really good habitat for them. But I don't think the issue, the way I understand it, for the cutthroats has anything to do with water quality, more so than non-native fish.
I think you asked, I thought it was water temperature, is essentially.
Water temperature is a big one. The way I understand it historically, and what I've seen anecdotally, is actually a lot of the Hondo, especially up towards the ski valley and above, is actually too cold to be good trout habitat. It's one of those weird places that might benefit from global warming. I hate to say that, it sounds insensitive, but we're actually seeing trout like get further and further up the Hondo. But obviously, you know, water flow, you know, temperature, like all of those things relate to each other, and you know, there's certainly plenty of threats. Again, anecdotally, I've seen the fish numbers in the Upper Hondo not quite what they used to be. That would, you know, obviously be both browns, cutthroats, rainbows, whatever's in there.
ATR?
Yeah, Chris.
One thing, there was some money in that green corridor appropriation to put those fish barriers in. It's been hard to get the highway department going.
I've got $250,000 into the county to install those slip liners, and come hell or high water, they'll be installed before June 30th. So I want to stay focused on the water quality question, but yeah, the question of the cutthroat trout, there is that section of the main stem of the Hondo starting more or less at the Ski Valley parking lots and down to the mouth of the canyon. That has been and probably will be for a while good trout habitat, but something appears to have changed in there, and it's hard to put a finger on exactly what that is. The question of temperature, just to get back to our quality, and then Sam, I want to maybe not get hung up on fish for the rest of the afternoon or the morning. The Rio Hondo is designated impaired, it's hurting, for temperature starting at the mouth of the canyon. So the water stays cold until it hits more or less Valdez, and then it gets real warm real fast. And you guys see it here in the summer as the acequias are taking water out, and as things warm up and there's really low flows, often stagnant flows, and there's even a section of the river that feels fully dry. The river is too hot there, and the Environment Department is aware of that, and it's a concern that we have when we did the thinning along the highway, was don't take too much of the tree cover off the river,
Shade.
because we don't want to see the water warming up in the canyon when it's already too hot when it comes out. So suffice to say, it's a dynamic system, right? And if you do one thing in one place, you're going to see kind of cascading changes in other places. The fish question, I think, is an interesting indicator. And to Peter's point, I mean, alkalinity pops on this little chart, and it's something we'll be looking at for the next few months. Greg, I saw your hand up in the back.
Do you guys also test, when you're testing water, also test the soil in the river as well as maybe algae and things to see if it picks up any chemicals or anything in there that would also be telltale?
I don't think so, Sam.
No, but we're back to
By
the,
fall, like things get trapped there first before they keep going.
short answer is no, but I think like talking about a next phase, looking at invertebrates could be kind of an indicator of the, like integrating the long-term water quality impacts of the individual events and also fluctuations so I think including sediments might, that's a little bit harder because it's so variable, but we haven't done that. It's a good point.
One other thing that came up yesterday was with the higher levels of bacteria in the water, would that maybe affect the fish and their eatability? And we don't know the answer to that yet, but is that something that can be tested and make sure that it's still good to eat with the higher levels of bacteria?
I'll take this one since I threw that bomb.
Okay.
I don't know. I want to know, as a guy who fishes the river and whose kids eat fish out of that river, I'd sure like to know if the fish are safe to eat. It's not within the scope of what Sam's up to. I asked that question during a lightning round, and I'm not going to let you off the hot seat until we do a lightning round at the end of this. But
Okay.
the idea was, it's a more complicated question to ask than you got all these results and these tables back for all these things. Is the fish safe to eat? There's a lot of extenuating circumstances that you wouldn't know for sure.
But I
So
think my understanding, I mean, I have a picture of Rio Grande cutthroat trout on my license plate, you know, so I care about fish, and you need to cook them anyway, so I think there's going to be naturally occurring bacteria, and in general, that's my layman's understanding of that topic.
yeah.
I think it's kind of a different issue than it's more like a fisheries issue than a water quality topic on its own, but
It is.
I'm
I'm
not trying to-
responsible for conflating those. I want to know, and so it'd be worth finding out, separate from asking
Well, it
Sam.
seems like there might be some data where maybe Trout Unlimited or other groups that are really focused on the fish, they say, well, if you reach this level of bacteria, then maybe you might want to eat twice or something. Maybe they have that information, then we can compare it to what we have.
Yeah, someone similar would have that. I'm going to stick Julia from Trout Unlimited.
I don't,
The best resource for that is the Game and Fish, and they actually have published certain, on their website, you know, any advisories, places you can't eat fish, and for what reason. Typically, it's things like mercury, the dams, you know, the lakes downriver, certain species of fish like pike, predatory fish. You know, bacteria being in the water, it's everywhere. You cook the fish, it's fine, as far as I know. But yeah, the Game and Fish would be the resource. Trout Unlimited would just tell you they're all too dangerous to eat because they want them in the river instead of in the frying pan. So
There's two more points I wanted to make before we leave. So the first one was, when this was started, you know, there's a pile of money, and what do you do with that money? Well, our looking at it was, we needed to talk to the people that had used the water the longest, to gather from them wisdom. And, you know, our brothers at Taos Pueblo and sisters at Taos Pueblo were very instrumental in reminding us what's important, as well as the acequias. So we have people from the acequias in this room that met consistently. Sylvia, Carlos, Dean Archuleta, Clifton Bain, who's not here today, that reminded us of these things that are important to the local communities. And I think that's what started to what we've got to right now, is going back to the roots. The second thing too is that this ain't finished. This is the first draft that we are presenting before you. I was on the phone yesterday with my college roommate who was head of the New Mexico Surface Water Quality Bureau, now since retired. We were talking and I told him, hey bud, could you go ahead and take a look at Sam's fact sheet for me and tell me if we missed anything? And he's like, I don't want to work anymore. But I'll do it for you, Pete. So those are the processes that we're going to go through. And I have another gentleman that worked for the Soil Conservation District that was head of the California Water Board when they cleaned up the San Francisco Bay. He was from Delaware. He's now living in Washington State, and he helped us start the groundwater program 20 years ago at the district. He has also agreed to take a look at this and see if there's an outside perspective, because sometimes when you're inside, you don't think of things. And as well as all the other people that will be looking at it once it's published. So you do have something that I would consider a benchmark. That is your line in the sand, and you only want to go up from that, not down. And that's the point I wanted to make about how the philosophy was on how we did this study.
Can I just ask, because I had brought up earlier about watershed and watershed designation, of which I don't know if exists or doesn't exist, but I know that that's part of the theme and a great study. Can I just understand what the possibilities are in terms of the Rio Hondo getting a designation in its beautiful state, or is there anything like that?
Rio Hondo from the Ski Valley down for about how many miles I'm forgetting, but until about the middle of the canyon, I think, is designated as an outstanding natural resource water. So that's one of the water quality of the river where it is now, it can't be degraded by future development. It doesn't mean development can't happen, it just means that they have to show that it won't degrade the water quality. And so that's a really great thing to have, and then so collecting these data too is super great to have more and more information of what is the water quality now, so that if we start seeing it degrade, we'll have all this great data to really show that something that's happening on the river is degrading it, and it's not meeting the protection that we have for it. So,
The Rio Hondo has that designation?
yeah, since 2022, so just a couple years ago.
Yeah, so I asked Shannon to mention that because that designation doesn't extend for the whole river, but it does come with the force of law. And it was supported by essentially the same folks who've been involved in this process for the last couple of years of trying to wrap our heads around what is the condition of the river. The outstanding waters designation is important for a lot of reasons, like Shannon mentioned, because if the water quality does degrade from where it's at now, then it has the force of law to adjust that, to change it, to require that it be brought back into compliance or at least to meet the standard that it was at. There's a huge hole in that designation, which is to say it feels good to put it on the river, but it's useless if nobody's keeping an eye on the river. And even though it's designated an outstanding water, that does not mean that people with clipboards from the EPA or the New Mexico Environment Department are actually out there keeping an eye on it. It's been amigos bravos for years when you all have funding and people power to go out and do it, and now a lot more muscle from the other partners and from Sam's team to really establish a comprehensive, what we call monitoring, keeping an eye on stuff. That has to continue going into the future, otherwise that designation is worthless. And so I think the second half, and I think the real optimistic going forward, the group that has been meeting is looking really hard at a tiny little obscure portion of state law which allows a community to establish what's called a watershed district. And a watershed district is created by referendum, so voters within a watershed vote on whether or not they want the thing. It exists under the auspices of the Soil and Water Conservation District, but it exists separately from that district. And in my opinion, it's the most effective mechanism to put control of this watershed in the hands of the people who live and work and play there. And that it doesn't solve all of the issues, but it provides a source of funding, whether that's grant funding. At some point in the future, that entity could approve a tax, but that would have to be approved by the voters, and I don't think anyone's suggesting that be the solution right out the gate. But it does allow for an elected board of people who live within that district to make decisions about how do we manage the use of water, how do we protect the quality of the water, how do we balance economic development with the health of the environment and the health of this watershed. And that's an entity, that's a district that would exist in perpetuity. So this doesn't become a one-off where $5 million fell out of the sky from the legislature. We did all this cool work. You guys came in and ate Frito pies in my office and we talked about stuff for a couple of years, and the thing just kind of evaporates. That becomes the vehicle by which the people who've invested time and effort and want to see this watershed be resilient into what's likely to be a very uncertain future actually have local control and levers at their disposal to be able to make strong decisions about management that protect the watershed and the quality and the quantity.
A unified voice that advocates personal responsibility in your watershed.
And the Hondo would be the first district of its kind to approach management that I'm aware of in the state.
On a watershed level.
On a watershed level. It would be a huge step forward, and as Peter said, it would be a great gift to the people who live in this community, I think, to be able to pull some version of that off. Because it would set a precedent for this is what local control of a watershed looks like. Jeff?
So the funding for the study is for quality and quantity, right? And
Just quality.
am I wrong about that?
Quality primarily, flow is measured because it factors in when you're discussing quality.
It said quality study,
It's quality.
but they go hand in hand. So if you're out there, why don't you just check how much is coming down?
Because I know that's not a lot of people on the lower Hondo on their minds. And I'm just wondering if beside the relationship between the quantity and the quality, there any other preliminary conclusions about the quantity of water in the river?
Okay, so I guess I have some ideas based on just my understanding. It's not necessarily based on this water quality study. So shall I?
Keep going, buddy.
I'll reflect on that. So we've actually been working in Rio Hondo Watershed since 2008 as part of, this is New Mexico State University, as part of different projects over time. And we're trying to kind of enshrine that in ongoing participation through this program called the Strategic Community Water Management Program that we're trying to get funded by the state. So that would actually be part of our state funding that would go to the Water Research Institute to have some ongoing support. And we have a somewhat reasonable idea about the hydrology. It's very complicated because there's a lot of interaction with groundwater that's going into the bed and banks. Well, the river loses and gains over its distance. So Carlos Ochoa, who's now a professor at Oregon State, did a lot of the work, and basically we have a acequia irrigation system that recharges the groundwater, and there are parts of the river, like if you go to the low flow part of the year, say August, for example, a lot of the water is distributed across the acequia irrigation system, but it ends up soaking back into the groundwater and going back into the river downstream. So by the time you measure the flow going into the Rio Grande, the consumptive use is actually smaller than you would think by going out and seeing. And there's spots where the river's almost dry, but it's been spread out over the floodplain. It's going back into the groundwater, back into the river. So what we actually have in mind for another study of the Strategic Community Water Management Program is to estimate the total consumptive use by different water users in the basin and try and get a better handle on not just what you see in the river, but what's happening for the actual, by consumptive use, I mean water that's going back to the atmosphere because it's evaporating off surface water, or it's going through plant transpiration back to the atmosphere. So I think when I think about protecting water quality, it's really important to keep that water budget in balance, the surface water and the groundwater over, and not just at one point, but over the entire valley. So I think right now, I would say it's in pretty good balance. We have pretty good connectivity between surface water and groundwater. And what we'll do for our spring report, back to the water quality study, is show how the flow changes as you go downstream. But I think the bigger issue is over time keeping that balance, not starting to pump a lot of groundwater or not somehow creating more consumptive losses in part of the watershed.
In terms of water flow, you know, USGS has water gauging stations. Is there one on the Hondo? Any thought, like in this program with potential funding that you guys have, to add another gauging station so that we can see that flow, or update the, because I believe the gauging station is just CFS, but we have ability now to update some of these gauging stations to show real-time data for turbidity, temperature, and all of those things. And that's just great infrastructure to have in the river, you know, to continuance for all these questions.
So at one time, this nation had a lot of gauging stations and a lot of data. So if you look at the data curves, which I have to look at daily when I'm doing river work, as far as flow, there's a lot of data pre-70s into the 70s. Then in the 80s, they started slashing USGS's budget and they started not maintaining a lot of the gauges that we had. So at one time we had several gauges on all the streams, whether it was Hondo, Rio Grande del Rancho, Costilla. That data has disappeared and you basically have one here, and one down on the bottom when it goes into the Rio Grande. So I think that's an excellent point in this time of abundance to make to our legislators, to get us the points we need to be able to go into the future and be able to manage for who knows what's around the next quarter. So I'm all for that. In fact, the district, my bosses considered funding stream gauges for USGS, but we just didn't have the money to spread it around on the whole county level. But we were very concerned about that point of missing data points from about the 80s till the present, that we don't know what's going on in the tributaries, we don't know what's going on in the smaller regions that sub into the river. So that's a great point, and something that as a community, you guys should demand.
It's worth mentioning, Nick, that the acequias that divert out of the Hondo now have a real-time data source, and I'll ask Carlos to talk more about it, where they can keep an eye on the flows in the acequias using the USGS gauge as their benchmark. I mean, down to the minute, you could get on there right now if there was still water in the ditches and tell us what's flowing where.
Yeah, there's 8 acequias that take water out directly from the Rio Hondo. There's 9 acequias that use it because the Revalse shares it off the Cuchilla ditch. But we have wares on 6 sites along the Rio Hondo that tells us real time how much water is being diverted by each of the acequias, because it has to do with our water sharing agreement we have between the 3 communities. So we monitor that, and we can see how much water is in the USGS site, which is right above the Cuchilla First Division. And we add all the diversion amounts for each of the 6 sites, and then we do the math, divide it, and we need to adjust it, we do. But what we notice consistently is that when you add up the amount of water that's been taken out by the 6 acequias that are being measured, and how much water is in the USGS site, there's usually more water taken out than what is measured at the USGS site. So that shows then that there's water that is taken out but is put back in. So we may collectively take maybe 40 CFS. Together, the USGS site is showing 30 CFS. So that goes to what we're saying, it's a system of gains and losses throughout the system. And the gains is return flow from the surface irrigation, springs, and such, and you see it here. Here by the river, you know, you'll see it's very low, but once it crosses the road, it starts gaining, and it continues on into it. So we're able to real-time go in and identify how much water is being taken out by each of the acequias, make our adjustments, but those are trends that we see happening.
So the short answer to your question, Nick, is yeah, we've talked a lot about it. And the reality is, how do you come up with the funding, not just to install the infrastructure to be able to measure and capture flow and any other metric you can with the station, but then be able to keep an eye on it in perpetuity. So it doesn't just exist for a couple of years and then get ignored or fall apart. Yeah, you got an idea, Sam?
I just wanted to follow up that. First of all, great description, Carlos, of the hydrology. Thank you. But actually, so the app he's talking about, if we had cell phone coverage, I could show it to you, but it's actually provided as part of the project. So we actually, at New Mexico State University, at the Water Resource Research Institute, came in 2008. There had been flumes installed, but they were never operational, and we got the data working from those flumes on the acequias that Carlos was talking about, and we had a couple projects where we were able to show the data to the community. Our project funding stopped, and fortunately, one of the community members called me a couple years ago. It's like, well, what about these data we need? And we had just then been funded by National Science Foundation, so we were able to put them back up and get them running. But right now, we actually have a technician at the Water Institute who's getting those data, storing them, and delivering them back to the community on handheld app that you can use just on your phone or your computer. So when I talk about this, this is just I wanted to make it clear that we're trying with this strategic community water management program as one way to kind of make it more of an ongoing resource. So if your project funding stops, the whole thing doesn't disappear.
That's the goal, yeah.
And I think what Peter was saying about, this is kind of just on the community participation, there's a lot of ways. We just heard at our annual water conference yesterday, the state has funding for infrastructure, and they want communities to express to them what their needs are, because they have money for design. I mean, you know this better than anybody, Peter, but they have money for design, they have money for construction, they have money for planning for design and construction. So this might be a perfect time to just put that around and say, we need some, you know, ways to turn this into infrastructure that's going to help the community for the long term.
Based on the current results from your study, Sam, is the water in the river safe to drink? Can I go drink out of the river right there?
So I would say no, based on what we already talked about.
Yeah.
But I would also put the caveat that the only rivers I would drink, I would not drink any surface water in New Mexico, just straight out of its source. But there are springs and other, you know, naturally filtered water with no inputs, where you could actually go and drink the water straight from its source. But I would be hesitant to drink any surface water in New Mexico because of parasites and pathogens.
Good answer. Based on the current results, is the water in the river safe to irrigate with?
Absolutely.
And based on the current results, is it safe to play in the river? Go swimming in the beaver ponds up in the canyon or something like that?
Yes.
How would you grade the quality of the water based on the results you've gotten so far on an A/F scale?
Yeah, yesterday I've been thinking about it. I'm still coming down hard on A.
You're giving it an A?
I give it an A. All right. It's really a great water resource, and it's really lucky to have the whole community that cares about it so much, because that'll help it maintain that into the future. And like I mentioned yesterday, if it is like a spring that's coming out of the mountain, crystal clear after being filtered for decades, soaking through the rock, that gets you an A+. But this river is naturally and in its human management state really excellent.
Cool. Any other questions for Sam that the group needs to consider? Otherwise, we'll just go back to milling about, drinking coffee, and finishing off burritos.
One question.
Yeah, go ahead, Greg.
Kids play in the river, people do things along the river. Should you ingest so much? What's too much? I mean, people will probably have some. Once you say it's unhealthy to do that, but there's got to be excess. I mean, a little bit here and there, probably not horrible. Or
So my understanding, thanks to the data that JR shared, is we haven't actually done the counts per milliliter, but there's no indication that the bacteria levels are exceeding standards. So unfortunately, I don't have those data, but my understanding is there's no data out there that shows exceedance of the bacteria standard.
is there any, has anyone gotten sick or?
Not to my understanding, but so
No, my kids are pretty careless, and they play down right there at the confluence where the Hondo comes into the Rio Grande. My oldest son, like, by the mouthful,
Right.
drinking water down there, and he's never gotten sick.
That's what I'm saying. I mean, quite a few just quite a bit over time. I mean, I'm not waiting directly to our results, but I think that's the spirit everyone's here for, is that what are we drinking day to day?
For sure.
I mean, that's what it comes down to.
For sure.
You know, like you said, certain filtration is not going to take out certain bacteria and certain chemicals or pharmaceuticals. So,
it will take out bacteria for sure. Any standard.
And metals.
I got
And metals. And nutrients.
All right. So Sam, or Greg, we might come back to you with Sam in the spring and do another one of these. All right. Cool.
Thank you, Greg.
Thank you for hosting us. Appreciate the burritos. And thank you guys for coming. Thanks, Sam.
Okay.